is the difference between deterministic and non-deterministic push-down automata. In non-deterministic push-down automata, on a single input symbol, we might have more than one next state. So let's assume this example. The language is given w raised to r. Now what this w is here? So as mentioned here, w is any string which is made up of a and b. So a or b and the bracket we have positive closure. It means any combination over a and b. So if I have any random string w, so after w, we have the reverse of the same string. Raised to r, it means what? Reverse. So the form string, we can call it as palindrome. Okay, and this will be our even palindrome. So let's start with the sample string. If I have random string as ABA, so if I consider it as a palindrome, W part is done here. So I will have W raised to R. So it will be like again ABA. So this whole string should get accepted by your non-deterministic push-down automata. Let's take one more example, like ABB. So this is my W part. So WR, we will have VBA. So this is what W raised to R. So ABB, VBA. This will be your palindrome string. Now, how to track this palindrome string using push-down automata? So we cannot predict initially what is the mid of this sample string. So initially we cannot predict what is the mid of this sample string. So we can consider it as a non-deterministic case where we are not aware like at what stage or at what state I have to consider like we reach at the mid of the string. So we are calling it as non-deterministic push-down automata. Now, how we can track this particular string? This part is W and the remaining part is WR. So here, initially we are assuming null character as the partition. Okay. Now, here, this particular string is made up of A and B and it can be any random string. So there can be a case like A come first or B come first, or it is ending with A or ending with B. So it can be any random string. So till mid, we are going to push it in the stack. Okay. And after that, we are going to perform pop operation. But it is not a random pop operation. We have to set the rule like in case of palindrome, what should happen? Whatever is your last character, it should be repeated over here. So whenever I'm reading this B after mid, I must have one B here. So if I take help of stack, this was Z0, which is the bottom of the stack. So if I keep pushing this A, B, B, it will be like A, B, and B. Okay, and we reach at the mid of the string. Now, for this W raised to R, our condition should be like whatever character I am reading as an input, there should be same character at the top of the stack. Then only you can perform pop operation. Otherwise, it will not get popped from the stack and you cannot reach to final state considering this is not a palindrome. So as we observe here, if it is B, here is also B. So if I pop it in the sequence like B, B and A, you will match with the string. So for pop, the condition is current input and top of the stack should be equal. Okay, and this condition you have to consider. Now let's see how push down automata can be designed. Let's say Q0 is our initial state. As it is positive closure, we can have at least one number of A or one number of B. So here we'll have a transition. Let's consider at the start I'm reading A alphabet and it is the first character. So it should be pushed in the stack, and at the bottom of the stack we have Z0. So let's say A, same character, I'm pushing it in the stack. What if we read B at the same stage? So we are going to push B in the stack. So whatever character we are reading, that needs to be pushed in the stack in this particular case. Okay, so after reading this first A or first B, now we can have any combination over A and B. So that can be represented as a loop. So on A, now at the top of the stack, I will have A, and we are performing push operation. So it will be A. Now, every time, whether can I get only A as a top of the stack, it can be B also. So the condition, we have to mention additional rules. Like when I'm reading A, there can be B also as a top of the stack, but still I will push A in the stack. Okay. So these conditions we have mentioned for A alphabet, and at the same time we have to mention similar kind of rules for B alphabet also. Whenever I'm reading suppose B, at the top of the stack I can have A or I can have B, but still we are going to push it in the stack. Okay, now here we assume like we reach at the mid, so we are considering it as a null character. So here I will have a null character. I will consider null as a top of the stack. I will keep it as it is. I'm not going to perform any operation on it. We'll change state to Q3. And now after this mid, I have to perform pop operation. So here we'll have a loop for pop operation because we are having multiple symbols. But the condition should be like if I read A, at the top of the stack, there should be A, and then I will perform pop. If I'm reading B, at the top of the stack, there should be B alphabet, then only I can perform pop operation. Otherwise, if you are reach at the end of the string, that is null, and at the top of the stack, there should be Z0, it means you reach at the end of the stack, and you're keeping it as it is, and this will be your final state. Okay, so this is how we can solve the language even palindrome using non-deterministic push-down automata. And why we are calling it as non-deterministic, because on the same alphabet we can have two different operations. Now let's try to remove this null. Then what will happen? In the same state, here I will include the transition of self loop, means this loop will come at Q2 only, and here I will mention A comma A null B B null. Okay, so what will happen when I'm reading A at Q2 state? I have two options. Either I can push A or I can pop A. So it is what non-deterministic state. Hence, we are calling it as non-deterministic push-down automata. So this is how we can solve this. Thank you.